Good afternoon, welcome back to the workbench. I've got here another USB charger I thought I'd have a look at as well, following on from the other one. This is from the same person, in fact, and it also doesn't work. However, I don't believe there's anything wrong with these ports. None of them are broken. They all seem totally fine. I believe when I last plugged this in, it just did absolutely nothing. There's no voltage output. There was nothing happened. And I already did crack this open before. I think I just take this adapter thing off. So it also has a design like the other one, with a kind of modular plug, although this one has its own sort of separate US plug in there. So it's, yeah, interesting. It's kind of 2-in-1, but you could obviously get different ones, like European or whatever. It could just plug onto here. I suspect it's probably a universal voltage as well. Yeah, same thing, 100 to 40 volts input voltage, so it can do anything. 5 volts out at 5.5 amps, or 5.4 amps, and it's got 4 ports it can do. So it looks pretty good, actually, to be honest. It's got all the certifications, assuming that they are correct and real. Yeah, and it says Aerocool on the front there. And yeah, it doesn't work. I've already cracked this open, so I'll just pull it apart again. This went together with some glue, and it was quite easy to get open with a screwdriver, I think. There were some screws from it, these ones here, which hold the PCB into the case, so I didn't break anything in that sense, not like the other one, which is nice. Anyway, this one I thought might be worth looking at because there's nothing burnt in here. Everything looks pretty good. It's just kind of dead, and it doesn't do anything. So that could be a good sign that it's something simple, like a startup resistor or startup capacitor or something that's gone bad. I don't remember hearing any sounds from it or anything like that, like a ticking noise or anything, which would imply, you know, like a short on the output or something, and it's power cycling or anything like that. So this may well be something easy. But yeah, I guess we can do some tests with that. Let's have a look. I'll get this out of the case here, and well, I think it's attached via some wires, yeah, to that. I don't know if this plug bit can actually come out or not, but anyway, there's enough room to look at it, so it looks pretty decent, to be honest. The charger is pretty well made. We've got three primary caps, it looks like, which is nice. I've got opto-isolator feedback. You've got these little chips on the output, which I guess are like for compatibility with Apple and stuff, maybe, on the data lines, that sort of thing. They communicate there, change resistance or something. This is not a multi-voltage charger, of course, it's just plain 5 volts. And that he also uses right angle ports as well. Any difference with these is they are very short. If you compare that to the one from the other charger, it's much shorter. So I'm glad I don't need to replace these, because I don't know how I'd find ones that small. Anyway, that looks like an output diode, probably. RU6100R, maybe? Pretty sure that's the rectifier. We got some capaps in there. Capacitors RG1701X. Again, I don't think I've heard of that. I don't know what that is. Can't see a brand on it, but yeah. The primaries are this GL thing, which I have heard of before, I think. But anyway, let's have a look and do some basic sanity tests. So first of all, I just want to see if we've got a short or open on the input. I don't know, see if there's anything obvious. So let's just test across the input pins and see what we get. Anything there? Nothing. Okay, let's measure from input to, I think these are the input wires. Okay, that's good. It could be a blown fuse, of course. Maybe the MOSFET has gone short or something. I don't know. But nothing seems to have exploded. So you got an input there. Let's see if we got connection to the bridge rectifier. Okay, we got connection on that side, so let's try the other one. Okay, we do have connection to that there. So the fuse is probably fine. I believe there's a fuse down in here, there, behind that red wire. It's all in heat shrink. It's a glass fuse probably across from here, I think. Yeah, so that's fine. That's good. So nothing's shorted. So yeah, this is looking like possibly like a startup circuit issue. We do have a couple of resistors here, which I'll have a look at there. Because the thing with switch mode power supplies, once they're running, they can supply their own power from an auxiliary winding on the main transformer, which gets rectified by a diode and sent to the sort of run startup cap. But to start up to begin with, they need some power to come into that cap to charge it up. And you see there R25 and R26 just below the bridge rectifier. Those look like what, 30, so 30, yeah, so like 3 meg ohm each. Yeah, those would probably be the startup resistors. You've got two in series because they're surface mount, and they don't want to have the voltage rating too low by just using one of them. But that could be what that is. Possibly R1 or R32. But what can happen is that those go open circuit, and then there's no startup current available at all to the power supply, and so nothing ever happens. The other thing that it could be as well is something to do with this little capacitor down here. That's going to be the sort of VCC supply to the chip, which looks like it's that little 6-pin one there. I don't know what that is. It's got a number. I'll have to look it up. Fortunately, they haven't scraped the numbers off, which is good. Yeah, so that's going to provide power to here. It's going to trickle charge this cap through some high value resistors, probably these two, maybe something over here, and that is going to allow the power supply to start once the voltage on this cap reaches the right threshold. So this cap being leaky or open circuit, or these resistors being open circuit or whatever, will cause the thing to appear completely dead and never start up at all, which could well be the problem. So that's what I'm going to guess here, considering we don't have a short on the input. And well, we don't have a blown fuse. I didn't actually check for an actual short. I suppose I should do that. Let's just check. Yeah, the output of the bridge has no short, which I'd expect, because if it did, the fuse would have blown. So yeah, of course the bridge itself could be open circuit, which is a possibility. Not likely, but it's possible. We've got a diode drop there. We should have one there. Yep, we do, and then that should be here, I think. Yeah, no. So the bridge looks fine. It's not open circuit. Those hardly ever go open. They're usually short anyway, so I wouldn't expect that. But yeah, so if I just trace through the circuit here and find the startup resistors, sort of figure out where they are, I can determine if they are good or not. I mean, I could just measure these ones. I suspect it could be these ones. Although those seem to come before the bridge rectifier, so they might be some like AC signal detection or something. But if I go to, I don't know, what is it, meg ohm range, measure that, what do we get? Anything? Nothing. Either that's too high. If they are 3 meg, I'll have to go to the... Okay, yeah. I guess they are. So that's 3 meg for that one. And is that one good? Okay, yep, 3 meg there. So that's fine. The other possibility, of course, is that this control chip has just died. Sometimes they just do that. They just fail. Often they blow up, but sometimes they just stop working. What else have we got here? That should be a 2 meg. Yeah, it's 205. These were... Oh no, that seems to be okay. We're getting less than 2 meg, but we are getting something, so that's okay. And this one's meant to be 3 meg. It's also less, but again, it's not open circuit, so that's good. And this is the startup cap. I wonder where that goes. Does that go here? Yeah, it probably goes to there, so that might be the these might be the startup resistors here. Yeah. So to the the positive side of that cap we go to here, and that goes to that resistor, I believe. Yep, and then that goes straight to the positive output of the bridge. Yeah, okay, so that makes sense. So these two are the startup resistors, I'd say. We've got a 2 megohm and a 3 megohm in series. These two there, that's R1 and R32. Yeah, so I don't know what these are for here. They could be maybe discharge resistors for this filter cap or something, possibly. Don't know. And then we've got this filter here. To make sure we don't have that open circuit or something silly. Nope, that all seems fine. Right, there's a couple of diodes here. We could test those just to make sure they make sense. Yep, that one's okay. That one's okay. Right, yeah, there's one here. That's a bit low, but that could be that's probably the rectifier for the auxiliary. If the startup resistors are okay, we could focus on that capacitor being bad, or it could just be the chip. The best way to test that would be just to see what voltage is across that cap when it's plugged in. I might just solder some wire there until I can just connect a hook to that. So I don't have to try and probe that and possibly short something out by accident. It's quite fiddly there. And I'll try to look up this chip as well and find out what it is. I don't know if that's a GLS or that's a logo and then GLS. Looks more like a logo, like a little triangle sort of thing. But there we go. Yeah. But I wouldn't be surprised. I mean, that capacitor is right next to the primary heatsink, so it could have just dried out and gone open circuit, and then you'd never get any voltage there, and the thing would never start up. It could be that. It could be as simple as that. Yeah, so I searched on Google for just like GLS, ASA-ATUC4PW I think it is, and we came up with an AliExpress listing that shows this chip here, AP3125A. It's a chip here you can buy some, so hey, we can at least get them if we need some. And then this one was posted about the same thing, same chip, same marking. Probably says it's in a 12 volt DC adapter. Yeah, and this person says it's this one, the AP3, same number as this, and we can look at the datasheet here, so I guess that's probably what it is. As I suspected, it is a basic PWM controller chip, and it does the stuff. So, or in this case, it doesn't do the stuff for some reason. So yeah, I mean, we've got like overvoltage protection, overload protection, latch out protection for different things. Actually, it says SOT26. Is that just, I don't know, maybe a different way of saying SOT23 6-pin? I'm not sure. But yeah, so yeah, this chip here, we've got an example schematic. So yeah, we got like here R4, R5 they show here. That's like the startup resistors there, and that'll trickle charge this capacitor C3. And when the voltage on that is high enough to run this chip, then it will start running. It'll start oscillating, driving the MOSFET, switching the transformer, and then once it's running, the rectified pulses from this winding, the auxiliary winding, will be rectified here, go through this capacitor and supply voltage to itself. But of course, if these resistors are open or this cap is bad, it'll never start in the first place. Or the chip is bad, which could be possible. So we got to see what's going on here. Does it say what VCC is meant to be? Should say here, yeah, VCC 30 volts max. It doesn't say. There should be like a range. Usually these things start up, yeah. UVLO on, so yeah, it'll start up at least about 16 volts to start, and then it can go down to 9 volts to maintain the operation, and if it drops below 7.6 volts or so, it'll turn off. And if the VCC goes above 30 volts or whatever, it'll shut down. So yeah. Right, so we're looking on that capacitor, we're looking for at least, 15, 16 volts. We're looking for that on that cap. If we don't find that, if it's, something else, then that would explain why it doesn't work, I suppose. So yeah, we want to test that and find out what it's doing. But of course it could be a fault with the chip or some other part of the circuit, but as a simple thing, it's often that. It's often just a fault with the startup circuitry. Sometimes it's just either a cap or resistor. So anyway, I'll solder some wires onto that thing and I can probe it safely, and we can find out what it's doing. So I've got this thing hooked up. I added some wires to the board there to probe onto. Got my multimeter set up, DC 20 volts. We should see about 16 or so, possibly more, but could see up to 30. But anyway, I don't know why it's actually showing voltage at the moment. I think it's because I have probed the circuit and it's charged the cap up, although it is kind of slowly going up by itself. So I don't know if that's dielectric absorption or it's just picking up mains interference on the mains input, and it's actually trickle charging the cap, which would kind of imply that the cap is fine. But anyway, we'll see when we give it full, well, not fine, but who knows. We'll see when we give it full power. Plug that in, switch it on. Yeah, we don't get anything, do we? It's just staying at like, that's weird. I have got this plugged in correctly, right? Yeah. You see? Yep, we got power there. So yeah, it's doing nothing. Well, that would explain it. The chip can't start up if it's only got half a volt on the capacitor. So yeah, that's obviously not going to work. So why is the capacitor not charging or even trying to charge? That's a bit strange. We do get continuity through that thing. I wonder, can I probe the main caps here? Will that work? I have got this unplugged now, so let me just see. Get anything on those? No. Nothing. That's odd. Hang on a second. Get anything out of here at all? I mean, 1 volt on that main cap there. And basically nothing much though. Yeah, just 1 volt. Huh. That's odd. I mean, the bridge test's fine, the fuse is not blowing. I don't know that we got continuity between the wire, unless we don't have continuity between this adapter plug thing and the actual mains input. I wonder if I could test that, maybe. Can we test between the plug pins on here? Let's put this back to continuity. See if we get continuity here. Let's see. Getting anything? Hang on. Let's see. Huh. We're not getting anything on that pin. Okay, that one's good. But the other one... Huh. Okay, that's strange. So is this thing bad? Is it this? Is this part the dodgy part? Maybe. we do get continuity there. We do get continuity here. Yeah, so we got continuity between the little fold-out plug thing on there, so maybe it's an issue with this thing. Maybe that adapter. So what if I go straight from the wire? No, that's fine. Yeah, no, hang on, looks like the neutral isn't on. I think I'm probing that right. Huh. Well, that'd be interesting, wouldn't it? So is it this thing that's bad? Huh. Could be. Could be. I need a screwdriver. Where's my screwdriver gone? Alright, let's just see if that, I can open this thing. That'd be funny. I mean, that's kind of annoying. Don't know how that comes apart. That comes open. I mean, nothing's burnt or anything. Like, the contacts are all there. Huh. Is it maybe like, I don't know, this one here, this one there looks like it's pushed up a little higher than the other one. Is that the one? Hang on, if that was there, no, that's the active one, isn't it? That doesn't make sense, I don't think. Let's just try pushing that contact down a little bit. I'll push them both down a little bit in case maybe they've gotten bent out of shape, but I don't see why they would. I mean, the thing's just going to be sitting there, isn't it? It's not going to do much. That's weird. I mean, we do have continuity between these pins, right? Let's just check really stupid thing. Is this whole thing good? Yeah, that's good. Okay, that's good. Yes, yes, okay. Let's put that back together. Wouldn't it be funny if it was actually this thing that was bad? How weird. Okay, let's try putting that back onto here. Okay, it's a bit tighter now. Let's see if we get continuity here. Wait, now it's worse? What? Now neither of them are okay? I just think these contacts in these slots are not actually touching on the pins of his. I think that's the actual issue. They're just like bent in a funny way. I have to find something I can get in there to try and get them back out. I wonder if the hook on this would work. What if we try putting that on there? I mean, I can see the contacts in there. You can see the contacts there and the pins below. I mean, that's the contact in here, and then that's that bit there is the actual pin of that part. So I wonder if that's... Okay, we got continuity on that one. We don't have continuity on this one. What if I touch... If I touch the contact directly, we do have continuity, yep, but if I touch that other contact, there's nothing. Okay, so it is that one there. It's not working. Which is the one that I thought was good, but apparently it's not. I don't know if I can get these out of the plastic. I don't think. Looks like it might be. Yeah, I think it might be molded in a little bit, maybe. Although it's kind of hard to tell. Well, hey, if that's all it is, I guess I could just use a. I could still actually use this. Just flip this out and put a adapter plug on it, and forget about this thing because it may be just stuffed. But I suppose what I could do, just to verify that, is to get an adapter plug. I think I have one around somewhere. Where is it? Yeah, we got this one here. This should work. So let me just plug that in. Yeah, if I plug that onto there, now let's do a test. Does this one have continuity? Yep, that works. Okay, so let's plug that one in. Let's just plug it in with that and just see. Alright, I've plugged it in again. Wired this up. We've got the 200 volt range on here. And it's showing 1.3 volts again. I don't know why. Put it down to, yeah, I mean it's showing that. I don't know where it's got that voltage from. Maybe a little bit of power did get in, capacitively coupled through the bad plug. I don't know. Let's give it a try. I think it's a blue LED or an LED of some sort down by the port, so we might see a light there. I'll turn this off, and I'll just see if I plug it in, do we get voltage on the thing? And yeah, we're getting power up, and there goes the blue light. And so yeah, 15 volts on the cap there, 13. Blue light on the output. Looks like it's actually working the whole time. Nothing wrong with the circuit whatsoever. The whole problem was actually this plug part. This thing here was something wonky with the contacts inside that. So that's interesting. I never thought that would be the problem. Yeah, but there you go. Goes to show that that can be the most basic fault sometimes. Yeah, this thing has obviously got no load on it, and he's got 3 nice filter caps on the input, so that's going to stay up for a while, I think. But yeah, so so I don't know, maybe I can fix this thing and bend the contacts to the right shape so that it actually functions, which would be useful. But I mean, hey, if I can't, I can always just use a other adapter thing on it instead. So either way, it'll work, I suppose. And so the only thing is to put it back together, I guess, and means I'll have to glue this or something. Or again, put some duct tape around it. I don't know. Either way, it should be fine. Well, that's nice. Not a fault I've seen before. I wonder how common that is with these kind of multi-adaptive ones. Maybe it's a design flaw in this particular design, or maybe it's something that could potentially happen with a lot of these things. I don't know. It's interesting. Something to watch out for. If you've got a little power supply or something that has a removable, swappable plug on it and it doesn't work, maybe the plug's bad. I don't know. Another failure mode to look out for, I guess, but that's good to be aware of. Nice to know. So hey, if you do have one of these things, especially if it's got something like this where you can flip out a plug out the side and plug it in, try it with a adapter plug and see if it works. If it starts working, then hey, maybe just throw this thing away and use the adapter plug, or try to fix this if you can. If it's one of those ones where, like the other one that I was looking at, this one here, of course, where the the adapter plug just goes to some little pins there. I mean, you can't really do that. You can't put another plug on it, obviously, so that would be an issue in that case. Alright, so I've just put it back together again. I'm going to do a little test on it. I don't know that I can fix this at the moment, or possibly at all, but it seems like one of the contacts is bent round behind sort of the little plastic ledge inside here that it's supposed to sit on. And yeah, I need to sort of like get a little tiny hook in there to sort of pull it out again maybe and try and bend it back into place. Lots of seagulls outside. Yeah, so I think I'd need like a little dental hook sort of pick thing they use. I don't have anything like that at all. I tried to use my little test hook things, but they're too bendy, they won't pull it back. So yeah, maybe I need to get some sort of tool like that and try. It'd be useful to use this, but otherwise I can use an adapter. Anyway, I've got it upside down because I want to plug in a tester. I don't really have any way of doing a decent test on it right now, but I mean, I'm pretty sure there's nothing wrong with the electrics anyway. I think it's the I mean, nothing wrong with the circuitry, it was mostly just that plug. But yeah, so let's just plug it back in again. Just give a basic test to see if it works in a sane way. Plug that in, we get the blue light. I don't know if you can see that. You can kind of see it in there, yeah. Anyway, it probably shines through the case at night. But if we plug this in, yeah, we get 5 volts on the output, so that's good. And then I've got like this power bank thing that we can plug in and see if it draws any power. This power bank is weird, it won't always charge unless you fiddle with the button properly. There we go, now it's actually drawing some current. Or it was. I mean, the voltage is stable. Of course this thing is supposed to be able to do 5.4 amps. But, you know, it's doing its best. Maybe this cable is bad. Oh yeah, I think it is. Anyway, I think this, well, basically proves that I think this thing does work. Yeah, I think this cable's bad. Looks like the plug part is broken. There we go, we're drawing like an amp out of it and the voltage is perfectly stable. So yeah, I'm saying that's fine. I think that charger is totally fine. The only problem was that plug adapter part of it is broken. The contact's bent or something and not touching onto the pins of the main connector, and that's why it doesn't work. So at least I can use it if I can't fix that. I can just use a little dodgy travel adapter thing. Other than that, it's fine. So yeah, hopefully that was interesting. Hopefully that was useful. Hopefully that brings to light another possible failure mode of electronics that you've never heard of before. I certainly haven't, but it makes sense. I don't know how that contact would have failed originally, but yeah, I guess it did. So maybe I can bend it back if I get like a little hooky pick thing that I can bend it with, and if not, well, I can just use it this way. But there you go. Hopefully that was interesting. Hopefully that was useful. And I'll see you next time.